Okay, so this topic that is about the unsupervised learning and clustering, and then so this is the outline of this topic. I'm going to talk about the introduction, which gives you some motivation why we are going to do the clustering as well as the unsupervised learning. Yeah, and then later on, I'm going to introduce different clustering methods from k-means clustering to the clustering for unknown number of clusters right here. Okay, so now previously when we talk about the supervised learning corresponding to one samples x1, we have y1, that is say two classes plus 1 or minus 1. So each sample will have one label. Yeah, so that's why we can use the supervised learning but now we are talking about that this, if we do not have these labels, and then how do we do classification? And then we call this is the unsupervised learning. So in why we have to do unsupervised learning? Because in some cases, collecting and labeling these samples will be time consuming. Just think about that. If we are going to do 10,000 10 millions, 10 billions samples, and then so if we are going to use human to just label that one by one, and then it is very costly. So that's why it suggests that we can use the unsupervised learning. We do not rely on the labels, but we can still do classification. Yeah, okay. And now unsupervised learning, that is, when we look at some applications, for example, the data mining application, which involve a large amount of content. So for this kind of application, unsupervised learning, that is very appropriate. Yeah, and also sometimes, as I mentioned before, the data set is a large amount, and then so we cannot just use the human to do the labeling. And then another one that would be for some applications, something like recognizing the text from a book, and then all those texts, and they do not change because the font will not change, and then so the color will not change. And then in that case, that means once we do the classification, unsupervised learning, and then those characteristics will not change, and then we can use the unsupervised learning forever, because we expect that even that we have some new samples, and then they will not change the characteristics. So we can handle some data set consistently if those data sets do not change with time or change slowly with time. Yeah, and some investigation also so that we will have some improved performance if we are going to use the unsupervised learning. It is mainly because that in some cases human can make error, as well as different people will label different things if the data is not clear enough. So if we are going to use the unsupervised learning, and that we will have one consistent algorithm to perform the classification. And then now, and also we can combine the unsupervised learning with the supervised learning. For example, in the beginning, I do not use the label. I'm given the data set. I'm going to use the unsupervised learning. Say we have x1, x2, x3, x4, x5, x6 right here. So I just simply used unsupervised learning to tell that this is a group, this is another group. So I'm going to label this to be +1, I'm going to label this to be -1. That is, I'm going to label for the whole group rather than individual. Yeah, so based on this label given by the unsupervised learning, we are going to learn the classifiers using the supervised learning. Yeah, okay. So now I mentioned many times about unsupervised learning as well as the clustering, and then so we have to understand what it is. Clustering, that is an algorithm. We are going to form groups of sample of similar properties. Now, in this figure, we have many samples right here and many samples right here. to us, we are able to group them together so that this is the first group, this is the second group, this is the third group, and this is the fourth group. So we call each group a cluster. In this case, we have 4 clusters. Yeah, so that means through clustering, we are able to put samples with similar structure, similar characteristic into a group. Yeah. Okay. So the purpose is doing the clustering. That is, we are going to think about how do we use it. Yeah. So when we form a group, and then what? The first thing, that is, we can use clustering for understanding better about the characteristic of the data. Yeah. So that means right here, if they belong to the same group, and then they will have similar structure, similar features, so we can just simply look at those structure. If we have a new sample comes in, we can use those features to tell which group it belongs to. Yeah. Another one, that would be clustering for utility. That is, we are going to extract the information from different cluster, so that, for example, in this group, if all of them, they have some similar strings, yes, maybe 1, 4, 2, 3, 5, and then so now we can just simply extract this from this group, so that when we send the information to through a network, we do not need to send through the, for example, the long string. On the other side, we are going to add them back. So this is a concept of compression to save the power. Yeah. Okay. So when we talk about the types of clustering, and then so in general, we break it down into 2 categories. The first one, that is partitional. Partitional clustering. It means that we are going to divide the samples into different groups. So that means each sample will be in one cluster. That is something like a pizza. We are going to divide into 4. In this region, that is cluster 1. This region is cluster 2. All samples, each sample will only be will be belong to only one cluster. Yeah. So hierarchical right here. That is, we have 2 approaches: agglomerative as well as divisive. Agglomerative, it means that I'm going to talk about this in the next slide. For the hierarchical, that means we are going to use the nested cluster. Yeah, nested cluster. That means we have sub-layers of the cluster. So each sample may belong to the cluster of the next layer, and then these samples will belong to more than one subclusters. Yeah, so we represent the clusters as a tree, and then so this diagram just illustrates what is agglomerative approach. That means we assume that we start from the bottom. If you look at this tree, and then we have many samples. For example, this is P. Each of them, this is a sample. Sample P, Q, R, S, T, or if you wish, you can just call this is X1, X2, X3, and so on. Yeah. So agglomerative approach, that is, it is a bottom-up approach. So we assign one cluster for one sample. So each sample belongs to one cluster, that is itself. And then when we move up, we just try to combine those samples with similar characteristics to form a subcluster. For example, PQ, it becomes one group, ST, it becomes another group, and then move upward. So this subgroup combine this subgroup, it becomes the overall data set. Yeah, so this is the bottom-up approach. Divisive approach, that is, it is top-down approach. We assume that all samples belongs to one single cluster, and then we divide into 2, and each subcluster we keep dividing at it, so that we know each sample belongs to which cluster. Yeah, so this is the top-down approach. So just keep breaking down the samples into different subgroups. And now clustering. That is, we are going to form groups, assign groups to samples. For example, this is the original point. We do not know which class it belongs to. So according to the layout, and then so we can divide into two groups, two clusters. And then some people may tell you that it is not two. It could be four, like this. Or someone will just tell you that we have 6 groups. Okay, now, clustering, we need to solve this problem. How many clusters we should have? Some clustering method, we need to specify how many clusters we would like to divide the samples into. Some algorithm will automatically determine the best number of clusters. Yeah.